Assalamualaikum warahmatullahi wabarakatuh. So for today, I would like to talk about the law of motion, or called as Newton's law. So there are three Newton's law. So the first one is also called as the law of inertia. So what is inertia? Inertia is tendency of object to resist any attempt to change its velocity and tendency of an object to continue in its motion. So back to the first law of Newton. What is the definition? The definition behind this is, in the absence of external force, the object at rest will continue at rest. Meanwhile, the object that moving in constant velocity will continuously moving at its velocity. So, force can be divided in two parts, that is external force and internal force. The external force comes from the environment, meanwhile the internal force comes from the object itself. So, it cannot change the object's velocity. So, the objects will in equilibrium, or the acceleration will be zero. In the second law of Newton, it shows us the relationship between the force and the acceleration. So, if the force is increased, and the acceleration will also increase. And if the force is increased, the mass will decrease. So, it shows that the acceleration will not be zero if at the non-equilibrium. So it will change the acceleration and not moving in the constant velocity. So the third law of Newton is about two objects. So if the objects that interact, as example, from the surrounding to the object is equal to the force from the object to the surrounding, as the famous saying, what you give, you get back. This third law is also known as normal force.
Assalamualaikum warahmatullahi wabarakatuh. So today I will be explaining on the friction force. So the direction of the friction force is the opposite the motion of the object, the moving object. So it is really related to the normal force because the friction force must be on the surface. So there are two types of friction force, which is static and kinetic. So for static, the short form that we use is Fs, and for kinetic friction force is Fk. So under the static friction force, the object is at rest. So we are calculating the Fs using the formula of μs, and the word n is referring to the normal force. So μs is the coefficient of the Fs. So next, the kinetic friction force, we're using the word Fk, which is the kinetic friction force. So kinetic friction force is having while the object is moving. So for the formula of Fk is mu k times n. Still n is the normal force, and then μs is greater than mu k of the same surface. Fs max is greater than Fk, because Fs max is when the object is slightly start to move, while Fk is once the object is moving. We use the formula of Fk. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. Okay, now I will explain about the free body diagram. So free body diagram is a sketch of the body and forces acting on the body. With the help of free body diagram, we can define the forces that are needed to be considered. So how to draw a free body diagram? So let's take a look for the M1. We have to place a dot in the center of the object. The object has mass, so it should also have weight and a force acting downward. Because this stationary board is on the surface, there is a normal force that acts perpendicular to the surface. Further attached to the board, there is a rope with tension applied. The tension force will act in the direction of the rope, and we also have friction force, which always acts in the opposite direction of the movement. So for the M2, the forces are only come in y direction only because the object is hanging. So we only have tension and weight for the forces acting on the object. Note that the tension on M2 is equal to tension in M1. So now let's move to the general cases. in this chapter, we have three cases which are on horizontal surface, inclined plane, and pulley system. So like in this slide, it shows the inclined plane case. So the free body diagram is a bit different than usual because we have angle, which is 30 degree. As we can see, our normal force is acting perpendicularly to the surface, but the weight acting downward. So for the sum of the force in y direction, we cannot use normal and weight instead of splitting the weight into x component and y component, like negative mg sin 30 and negative mg cos 30. So for the sum of the forces in y direction will be normal and negative mg cos 30, while for the sum of the forces in x direction will be tension and negative mg sin 30. Why tension? Because there is a rope attached to the tree. So finally, we can define the sum of forces in each x and y direction.